A solutions architect is somebody that has many years of experience in IT and is able to prefer solutions. Okay. Because how can you say you can prefer solutions to a company when you haven't actually had experiences to understand the differences between possible solutions? And so you need to be hands-on yourself to be able to say, I am a solutions architect. Why do you need to be hands-on? Because a solutions architect is somebody that is able to test his solutions before he presents them to the company. And you test them through what is called proof of concept, POC. So to do a POC, you need to be able to log onto Linux servers, implement certain solutions, test that this thing is going to work, have a number of options, have option 1, option 2, option 3, and say, okay, now I'm presenting a solution. I'm going to draw the diagram and say, to build a data pipeline for this team, what we're going to need is to have an ETL solution using this technology, that technology, that technology. Because I have done a few tests using 2 technologies, and I can tell you that technology A doesn't fit our business requirement. It is B that will fit into it. So you're able to come up with a documentation with your pros and cons, your findings, and your diagrams, and then you can prefer a solution. Now you can tell that it makes sense to have technical hands-on experience from a DevOps perspective, first of all. Let me see if I can mute that person. All right, thank you. Okay, so it makes sense to, first of all, have that hands-on experience as a DevOps engineer, because a solutions architect presents the solution and DevOps engineers implement the solution. Okay, and if you don't have experience from a hands-on perspective, how then are you able to prefer a solution and even guide your engineers? Because DevOps engineers are still going to come back to you and question your architecture. So if you don't have hands-on experience, by the time they start drilling you on questions, how are you able to defend it? Because they will ask you things like, well, we don't think this is going to work. These are my reasons. And then you can say, well, I've actually done a POC on this. It's going to work, and this is how it's going to work. You're a solutions architect. You have more experience. You're going to be able to guide them towards the implementation of it. So what I generally recommend for people is, if you do want to become a solutions architect, become a DevOps engineer first, have the skills, and then you can present yourself as a solutions architect. So when you start looking for work, having gone through all of these, you can actually pass for either a DevOps engineer, SRE, cloud engineer, solutions architect, whatnot. Okay, so that is our number 1 sorted out for today's session. So any questions before we begin to design our infrastructure? All right, cool. So I take silence for we are good. Okay, so let me bring out so let's go to diagrams.net. And before that, what I would do is actually bring this up. I will just have a brief walk through this and understand the business requirement first of all. So what we're going to be doing is to build an infrastructure that is able to allow a company to service multiple websites or even mobile application. Because at the end of the day, what you want to be able to do is to have an infrastructure that can host your applications, whether it's a Java application, PHP, JavaScript, it doesn't matter. Ultimately, these applications are going to be running on servers. For now, we're focusing on VM virtual machines. So no containerization here. So for those who have gone ahead beyond Project 15 and understand about Docker and all that, don't think about that for now. We're not doing anything like that. We're just going to be provisioning virtual machines, and we configure our applications to run there. Now, this use case is such that we want to be able to have multiple websites running in the same infrastructure. So if we say infrastructure, we're talking about our networks, our databases, our servers, our security groups, and things like that. So the same set of infrastructure is configured to allow multiple websites to run. Now, multiple websites may actually not be the use case for some companies. It may actually be the use case for multiple subdomains. So for example, Diary.io, as a company, as a website, we can have multiple subdomains like finance.diary.io, hr.diary.io, what else? Customer service.diary.io, webinar.diary.io. I mean, some of you guys came through by watching our webinar, first of all. So as a business, we could require multiple subdomains, but we don't want to have multiple infrastructures because that would mean we're spending a lot of money. You can imagine having an entire infrastructure like this and dedicate that to one subdomain for HR, and then have another subdomain with its own infrastructure. Having things like that will put a lot of pressure on our finance because spending on cloud costs doesn't come cheap at all for companies. So the best way is to have an infrastructure that when you go to the browser and you hit the address, it resolves and hits this infrastructure. And it doesn't matter how many of the websites or subdomains that you go to, they're all coming to this same infrastructure and reusing the entire infrastructure to service requests to our customers. So that's what we're going to be building out. But in the course of building that out, we're going to be touching on different AWS services. What is a VPC, a subnet, internet gateway, target group, auto scaling, all those different buzzwords and concepts in AWS? We'll be talking about them while we're designing the infrastructure. Okay. So it may take us today and tomorrow because I envisage there will be some back and forth and questions and things like that to complete the whole infrastructure. So what I would then do is to give you videos from previous batch so that you can watch during the week to then implement the infrastructure manually. But by the time we come back next week, we'll then implement it together. The reason I will highly recommend for you to watch previous videos is so that while you're trying to get your hands dirty doing it yourself, you may start having a lot of questions, and then you can come to class next time and then we can start talking about your questions, and then you can question me as I try to implement it, and then we can go through that. Once you have understanding of this infrastructure and you're able to do this, trust me, most other infrastructures are going to be based on this similar concept. Okay. If you join an organization and they're trying to do something, even though the requirement is not the same thing, it is still going to be around similar infrastructure, similar concept, similar reasons for deciding to break out an infrastructure and its network in a certain way. Okay. So it's very important. This is very important concept, and just try to understand it as much as you can and ask questions. Okay. All right. So before I start to design, let me look at the time. So we have about 1 hour, a few minutes. So before I start to design it from ground up, okay, I'm going to walk you through. So what's going to happen is there is 2 different types of users that will require this whole infrastructure. So we have our DevOps engineers. It could be also application developers as well. Whatever engineer that needs physical access into the servers running in the infrastructure. So if I say physical access, I don't mean taking yourself there physically. I actually mean being able to do SSH into the virtual machines. And I'm sure SSH is not new to you. That's why it's important for you to have gone through project 1 to 15, because you would have done that many times. And the other kind of customer is our customers that's paying the business, right? So they need to go to a website to be able to access the infrastructure. So if you go to facebook.com, all you know that you're doing is just going to Facebook. But in reality, there is a whole infrastructure running behind that facebook.com or whatever.com that you're typing in the browser, similar to Diet. So this infrastructure, let me tell you what it's going to be doing. So there's a layer, first of all, that resolves the domain name into an IP address. Because you know your VMs, your virtual machines, they have their IP addresses, but it doesn't make sense for you to give your customers IP addresses. I mean, no one remembers numbers like that. Even if you remember one, say for example, 35.214.76.178, if you remember one, how many websites do you have to visit on a daily basis for your personal life, for your finance, your bank? There's so many websites. So it's not possible for you to remember all the websites by numbers. So it makes sense to have a human readable name that you can always remember. At least if you know you're banking with GTB or Barclays, you can always remember that and go to your browser and put it in there. So there is the DNS, which is the domain name service, that actually does that for us. And in AWS, the service that takes care of that is Route 53. So Route 53 in the name. And by the way, in case you didn't know, 53 there is the port number that the actual application uses to listen on when you configure DNS on the server. So back in the days, if you have configured an actual application that does DNS resolution, like named, you would know that they listen on 53 port. And I think that's the reason why Amazon has chosen to name that service Route 53. So it does the DNS resolution, which resolves the name and the IP address together. And what happens is it hits the network of your AWS infrastructure. And by the way, the IP address it's resolving to is actually a load balancer, because you are not going to put your application on the server and just give your users the IP address of that server. Okay. What if that server crashes? What's going to happen? It means your users are not going to be able to reach the website. So bulk of our decisions is going to be based on how do we ensure we have high availability? How do we ensure that we have disaster recovery so that when there is disaster, we can quickly recover from it? Or making sure that we have high availability such that if a server goes down, there's always another server that is able to render pages to our customers. Okay. So for that reason, you have the DNS resolving to the IP address of the load balancer. So the job of a load balancer is to listen for a request and spread it across servers running behind it. So of course, you guys have worked with load balancing from previous projects. And you're beginning to see the reasons why it's important for you to have done those projects before today, so that these concepts are not new to you. And then you just know that, oh, a load balancer just takes care of taking the request and spreading it to whatever server you've configured to listen behind. Now, since it's going to hit this load balancer, it takes that request and forwards it on to some servers that's running Nginx. I'm sure you've also worked with Nginx. You understand that Nginx is able to do load balancing and reverse proxy. So if we have a load balancer here, why then do we also have Nginx there? What are we using it for? Well, we're using it to do reverse proxy so that it can listen for different applications and be able to forward them on to the respective application or domain that we're servicing. So remember, the requirement is to ensure that we can service multiple domains or multiple subdomains. This is where we'll do that configuration. As a matter of fact, the configuration also starts from the load balancer here, but it's also important we have a proxy here so that the host header information is being captured so it can forward it on to the respective application. So this is showing an example of two different applications. So we have a WordPress site, we have a tooling site, and with the host header information, it's able to pass it on to another load balancer, which is an internal load balancer. So the reason why we would have a load balancer and another load balancer here is because we have a subnet that is public here, and the rest of the subnet are private. We don't want any of our infrastructure to be exposed to people on the internet, because the internet is a scary place to be. There's a lot of excuse me, there's a lot of bad people out there that all they want to do is to steal your data, hack into your system, and just cause you harm. And so we need to be able to protect ourselves very, very well. So one of the ways to do that is to ensure that we only present very limited visibility to the public. And the most visibility we can give them is this load balancer, listening on HTTP. So with this load balancer, you can't even do SSH onto it. Okay. And so for that reason, we have reduced the level of threat that can potentially harm our organization. And so what's going to happen is we place this load balancer in a public subnet. Okay. Because it's in a public subnet, that's the only reason why people can access it. This is an internal load balancer that is placed in a private subnet. If we were to use this load balancer here, people won't be able to reach it just because it is a private. It's in a private subnet. It's an internal load balancer. It doesn't have an external public network interface. Okay, so this is the load balancer that is publicly available. It takes the request and sends it through a funnel that goes all the way like this and hits this internal load balancer. Now, this internal load balancer takes that information, it has all the header information, and it basically just passes it on to the respective application. Now, notice that we have the same thing on the left and the same on the right. That's because we are taking care of high availability and disaster recovery. High availability in the sense that if we have multiple servers, they are going to be spread across availability zones. So there's an availability zone on the left, there's another one on the right. So if we have, let's say, 4 servers, we can have 2 on the left, 2 on the right, and then the service can be such that if we have 100 million customers using our application, 50 million of them can go to the left, 50 can go to the right. So we're not putting pressure on a particular server. And also, if this whole availability zone gets damaged for whatever reason, AWS is down, we're able to fail over onto the one on the right and continue servicing our customers. Remember, the goal is to ensure that we're able to make our service highly available. We have disaster recovery taken care of. And that's the reason why we did even present the IP address of our actual server hosting application to the customers in the first place. Okay. That's why we had to go through all the stress of doing all of these things. Okay. First of all, HA is taken care of, high availability, disaster recovery is taken care of, and also security is taken care of, because our application, our data is all within a private infrastructure. And then finally, we have a layer here that takes care of our database. So we have another subnet that takes care of putting our databases separated from the subnet where our applications are. It's also a security thing because data is crucial and we separate it very, very much from the rest. So applications have connectivity to the database and nothing else. So only this application will have security configured to be able to access this database. And so you can imagine that it's going to be hard for someone to come up from the internet to eventually reach our data. And this also buttresses what someone said earlier on. I think it was Psycat. Yeah, trying to get your name. So Psycat was asking about having working with a financial institution. They're concerned about putting that data in a public cloud like AWS. What are the decisions that can be made for such things? And we mentioned that rather than have your data living in AWS, you can actually separate it and completely have it hosted inside a private data center. So imagine you have your MySQL, not RDS, because RDS is a managed service provided by the AWS. We'll go through all of that when we're ready. But this is basically saying, oh, okay, we're just going to have our database outside AWS, and then your application can then connect to it. So there's a different kind of connectivity and configuration that will be done. You can use direct connects to be able to connect your applications from AWS to your private data center. That's beyond the scope of what we could be doing, but that's also a possibility. Okay. Actually, I'll just do this. All right. And then you will then notice that there is an arrow from here all the way to here. And that's the way we can ensure that whatever data is written here also gets written on this other availability zone. Also, high availability disaster recovery, because from a disaster recovery perspective, if this AZ goes down, this database will become the write database, because initially this will be the write, this will be the read only. Read only because you can't have your database, you can have two databases available to do read and write at the same time. You can have data inconsistency issue. Now, some RDBMS platforms are able to deal with multiple writes. They have certain configurations for that. They all have their pros and cons, but this setup has a read and write instance and then has a read-only instance. So what happens is, imagine a database on this AZ needs to write into the database, it connects here to write. Even the one on this availability zone, if it needs to do a write, it actually talks to this one for write. Now, when they need to do read, they can read from either of the two because the data that is here is being replicated here. Now, there are certain configurations that you can have, whether synchronous or asynchronous. We'll talk about all of that as well when we start implementing it. But that is also around whether or not you want speedy access to the database or you're more concerned about data consistency. So we'll talk about all that as well when we start the implementation. So it's very important we walk through these before we start designing, because what I wouldn't want you to have is, oh, we're configuring things, we're designing things, but why are we doing it? What's the end goal? What exactly are we trying to do? So it's very important we have this understanding, first of all, before we then start designing and implementing anything. And then it will make a lot of sense to you that way. So do you guys have any questions so far? Any questions?
Yes, sir. Yes, sir.
Okay, yes, shoot.
You walked us through with the customers how to access the infrastructure. What of the DevOps? Seems that you're doing now.
Sorry, I'm not sure I got your question.
The DevOps connection to the infrastructure.
Yes, thank you. Thank you very much for that. Okay, I skipped that. Okay, so we have the DevOps side, and what they are interested in is to be able to SSH into the servers. Okay. Now it may be DevOps, it could be any other, person, anyone that is interested to actually physically SSH into the servers. This is what is going to be happening. So this is an actor right here. He does SSH command. He already has the private key to connect. And because all these servers right here, they're within a private subnet, he can't actually go directly from the internet into a private subnet. So the best way to do that will be to deploy a server in the public subnet, which he's going to hop onto in the first place. And that's why it's called a bastion server. So a bastion server is also called a jump box. Okay. So it's a jump box because you jump onto it first of all, before you then jump onto the main server that you actually have interest in. Okay. So what's going to happen is this server is within the entire VPC. So the VPC is a virtual cloud, and it has its own network. Before you started uh, separating and dividing them into subnets, right? Now, this subnet, what makes it a public subnet is the fact that it has a root table that is able to allow people to connect to the internet. So what is called an internet gateway that you get to attach, and that way it becomes a public subnet. That means people can access it from the internet. So when you hop onto the server with the public IP address, you're able to get into it. But because this bastion is within the entire private network of the VPC, it also has private network interface. That means it has a private IP address as well. So the DevOps guy is not going to be able to SSH into it using the private IP. He's going to use the public IP. But through the private IP, which is the private network interface, it's able to then get onto the other servers. So that's why when he gets onto this server, he can then do SSH into any of these other servers, provided the security group has been configured to allow it. And that's how your engineers are able to get onto the servers and do whatever they need to do, configure it, maybe create users, run configuration scripts like Ansible or whatnot to then carry on doing further configuration. Okay, so that's I hope that is clear. Okay, any more question? Okay, someone has asked here to shed a bit more light on reverse proxy because she doesn't quite understand it. So let's do that quickly. So Nginx is an application that can be used as a web server, a reverse proxy, or a load balancer. Whether it's used as a reverse proxy or load balancer, it's a proxy. So let's start from understanding what a proxy is. A proxy is, for example, what this load balancer is doing right here, because it's accepting a connection request and forwarding it on to something else. So it's not the one that is actually doing the work or running the business logic. If you connect to Facebook, for example, and you try to upload your picture on there, there is a backend application that processes that image, compresses it, and stores it in the database or do whatever it's asked to do or being programmed to do. But the fact that you're hitting this load balancer, first of all, does not mean that it's the one that's doing the job, even though it's accepting your request and telling you, oh, your upload is successful and all that. It's not the one doing the job. It's actually forwarding it on to something else. Now, when you configure a an application like Nginx to only take a request and just forward it on, then it's doing a reverse proxy because it's just taking it and just doing a proxy job. Accept, forward, accept, forward. That's all it's doing. Load balancing is when it's doing the accept and forward, but it's using an algorithm to loop over a number of servers that it's forwarding it onto. And so if you have 3 servers, it goes, accepts the request, forwards it onto server 1, a new request comes, forwards it onto server 2, a new one comes, server 3, and it keeps going like that. 1, 2, 3, 1, 2, 3. Each of those servers have the same configuration, running the same application. So whatever you send to them, they're able to process it. So if this one receives the request to upload a file, okay, it processes it, compresses the file, stores it into the backend database. Each of those servers are talking to the same database, but they're able to process your request. So they are stateless. So it doesn't matter who receives the request, they're all able to service it. So rather than use one server that can die and make your application go down, not available, okay, you can then have a load balancer that is able to spread the load across multiple servers. But if it's just talking to one server and it's just, forwarding it on, then it's doing a reverse proxy. Now, it's possible to configure it as a reverse proxy to send the request to another load balancer. Okay, so in that case, it's not Nginx is not doing load balancing in that case, especially in this instance that we have right here. It's not doing a load balancer here because it's just taking the request and forwarding it on to another load balancer. Now, it's possible for us to just have a load balancer here in the public subnet and just directly send it to another load balancer in the private subnet, and you'll still be fine. The reason why we have the configuration here to have a layer for reverse proxy is just to, first of all, for learning purposes, so that you can understand the differences and you also understand how to configure Nginx and just continue having your Linux experience to getting onto the server and doing stuff. But another reason why you might want to do that is because there may be certain features that Nginx has that your load balancer is not able to have those features. So for example, you may want to even limit your customers to, when it comes to downloading stuff from your website, you want to be able to limit how much size they're able to download within a period of time. So that's why you see you go to some websites and you're trying to download a file, maybe it's a 10 gig file. Even though you have a very fast internet speed, you're still not able to download over maybe 500 MB per second or something like that, so, or 20 MB per second or something like that. That's because there is some configuration on the server that has limited the rate at which you can do such downloads. Nginx has that feature, for example. Or maybe to dynamically locate, service a particular request based on the IP address of who is requesting it. Okay, Nginx has such features, and that's why some pages will load just because you're in a particular country. If you go to another country, it's a different page that will load, and you're hitting the same domain. So for such configurations, you can leverage Nginx to be able to do that from a reverse proxy perspective, and then forward it onto a load balancer that then spreads the load. I hope that is clear. Okay, so I'm thinking, should we actually start the design or start the design fresh tomorrow so that all the information we've had tonight can just sink in, because information overload sometimes can be a problem. So I don't know why it's raising up his or her hand. I'm not sure.
Yeah, it's
Okay.
I'm lady. I wanted to ask if it's possible then to use Nginx for the load balancers instead, since it can also do the work of a load balancer.
Absolutely. You can. Yeah, absolutely. You can do that. You can just also remove these and just use Nginx to do the load balancing directly and just get it to do that. And then again, for learning purposes, just so you also understand that there is public load balancer, there's internal load balancer as well that you can use. So, but yeah, you're right. You can actually just use Nginx to do the load balancing and it still does the same thing. Okay. All right. So let's start our design. So someone has said that we can start tonight. Okay. So we still have a bit more time anyway. So let's get started. So start. And by the way, this it's diagrams.net. Let's create a new diagram. Let's name it AWS Masterclass. All right, blank diagram, let's create it. Okay, I'll just put it in downloads because I'm not going to be using it. Create, AWS Masterclass. Okay. So if you had to do this yourself, you can do the same thing. The reason is it's going to store a file on your local computer, and then that file is an XML file you can always upload to view your diagram. You can even send it to someone as well. Okay. All right. So what I'm going to do is I'm just going to drag this to my other screen because I'm going to be using it as when I was in secondary school, we call it Expo. So for my Nigerian people, you understand what I'm talking about. So I'm going to be using it for my Expo, which means I'm going to be stealing from the side to look at it. Okay, 1 second. All right. And then we have, okay, so we have this. So if you've never used diagrams.net before, it used to be draw.io. They've renamed themselves to diagrams.net. And it's a free tool, so you don't have to pay for it. There are some other tools like Lucid Chart. So with Lucid Chart, it's a paid tool, so you pay for it, but it's a lot more advanced. It has a lot more features for designing infrastructure and things like that. It integrates with a whole lot of services, and the user experience is just amazing. Okay, so I mean, if you want to spend a bit of money, you can do that, or if you want to recommend it for your company that you're working with, you can also do that. So they haven't paid me for this advert. I'm just saying it because I've used it. It's amazing. Now, diagrams.net is amazing as well. It does the job, to be honest. You can have whatever diagrams you want to do, design there. So yeah. Okay. Yeah. Saikat said he used it to design network infrastructure. Yeah, it's an amazing tool. Okay, but we're going to be using diagrams.net, and you can actually search for shapes here. So if I type in AWS, for example, you'll see some of the AWS shapes here that will come up. You can load more for more results. Okay, and then there are other shapes, arrows, rectangles, circles, different things, and there are miscellaneous here as well. So you can get creative. I'm very bad at designing, to be honest. So I've spent too much time on hands-on technical stuff. But for those who will be focusing their career around solutions architecture, you spend a lot more time designing. So, it depends on where the career takes you, to be honest. So when you start looking for work, whatever comes first, solutions architecture, DevOps, just take it, get your career started and figure out where exactly you want to focus on, and then build more expertise around that. Okay. All right. So let's Let me see. Probably square might be better. Then we can expand it. Okay. Okay, so this is going to represent our AWS network. So that means everything we're going to be doing is going to be within this network, okay? And then let me see what happens if I drag something else on top. Okay, so that's fine. And I can move that. All right, so what I'm going to do first of all is to search for AWS VPC, just to show that, what is that, VPC pairing, gateway, VPC. So just to demonstrate that this is our VPC, which is our virtual private cloud. So we just put that, yeah. And we can just write something. So if I double click it, it puts this prompt there where I can type stuff. So you can just write VPC. Okay, so infrastructure is coming up. And let's bring up our DevOps engineer. So if we type in actor, so you can have an actor here. Okay, if you like, you can use a different kind of actor. So I'm just gonna, oops. Okay, we don't want an arrow yet. So I'm just gonna double, oops, again. Just bringing up the arrow. That's not what I want. And let me just move it away from it. What I need is this sign. You can see that sign like a cross. That's what you need to be able to move things around. Okay, so I just want to double click on it because this plus sign is what is causing that arrow to come up. You can see this plus sign. If I click on it, hold on one second. Oh, maybe not actually. Okay, so I just double click on it and it's bringing up this arrow, but we don't need an arrow yet. Okay, let's remove that. What I want to do is to be able to rename this thing. Let me see, maybe I can enlarge it first so that it's big enough for me to be able to click on. There we go. DevOps. That's our DevOps guy, yeah? And so I can do that. So I can copy it, Control C, or right click copy, and then Control V to paste it. So I did Control V to paste it, but you wouldn't know because it was exactly on top of the image. So I had to use my right arrow on the keyboard to drag it to the side. So what I want to do is to also name this our customers. Yeah. There we go. All right, so just like we had it previously, so we have these two guys. So these are the two different actors that actually need to access this infrastructure. So what's going to happen next is we need, actually, I think we should do this. So, okay, there's one more thing. Didn't have it open. So there's a note that I have that actually has a step-by-step of the things that we need to do. For now, it's a good thing because we've gone through the whole infrastructure, so we already know what we want to do. But from tomorrow, I'll find that note and then we can follow it step by step because it's going to help us a lot. Okay, so what we're going to do next is we're going to, we have the VPC. So we're going to have the availability zone. So first of all, what region do we want our infrastructure to be? So with AWS, they have data centers in different places because, sorry, I'm trying to read, this can show us how you created a blank space with VPC. Okay, so you want to see how I created this blank space. Well, all I did was just drag this square in here, and I just dragged that to make it big, and then I dragged the AWS VPC image onto it, and then resized it and put it on the side. Okay, so that's how I did that. So I want to remove this. All right. So the next thing we want to do is to have our regions. So we decided what region we want to have. A region is a representation of a data center. And what is a data center? The data center is that place that Amazon keeps all their servers. So let's see what a data center looks like. Data center, AWS. Let's even see if we can find images of AWS data centers. So you can imagine, okay, look, this says Amazon plans new data center outside where? Let's even have a look. Let's click on it. Outside Paris. So you can imagine how huge the data center is. Let me click on that. Let's see what comes up. Okay, I'm gonna zoom in a little bit. So this is a place where they keep all the servers. So you can see this is server. But you may not actually appreciate that. So let's go back into the pictures and let me just show, for those who haven't actually been to a data center before, let me show you. So you can see all of these are servers. Now, think of a server as if you've seen a desktop computer, or you've been to a cyber cafe, they would have the CPU and then the monitor. You see that CPU is a typical example of one server. So it has the motherboard, the network cards, and the graphic cards, and all those things. And each of these each of them has a rack that has servers in there. So a whole rack like this can have like maybe 20 or 30 or even 50 servers. Okay. So you can have rack, all these racks of servers. What you're doing when you go onto AWS to create an EC2 server is you're basically taking a slice of the servers that they have here. And because of virtualization, one server within a rack can actually provision probably hundreds or even thousands of virtual machines. So the virtual machine EC2 server that you're provisioning, that you're seeing in your console, is actually a tiny little bit space from from the AWS rack in the data center. So when they have a data center, you can imagine this. This is a whole data center that has all the servers and racks and all that. This is a whole region. So from this news that we saw here that says Amazon plans a new data center outside of Paris, that data center is a region. Okay. So when you're designing your infrastructure, then you have to decide which region do you want to put your applications, or do you want to build your infrastructure? And there are reasons why you choose certain regions over other regions. For example, if you service customers more in the US, why would you want to have a region in South Africa? Okay. Or why would you want to have a region in India? So your customers are in the US, you have a region in US, and you put your infrastructure in the US. From a latency perspective, your applications, your servers, your websites will load faster than if the traffic has to go all the way from United States, where your customers are, to talk to your servers in Africa. But if your customers are in the United States and you put a region in United States, then of course the latency is going to be a lot shorter and your applications will load much faster. So that's why you have to decide on which region. And also, some regions have certain AWS features that some regions do not have. So if you understand the business requirements, you've designed the infrastructure already, your solutions architect already understands the requirements, and based on the things that he or she knows, understands that the services in AWS that will be required are available in the region, then you make the decision to go to the region, okay? Because it's possible for you to rely on some services that are not available in certain regions. So they have regions in the US, in Europe, in India, in Africa, in Asia, all over the place, and expanding, they keep on expanding. Right. So what we're going to do is, let's say we've decided that we want to use a region in London. Well, Ontario, we are London based, and we believe most of our customers, it's a location that is close to our customers in Africa, in Europe, and also in the United States. It's like a central hub for a lot of people. So we can decide, okay, we're just going to have our region in London. If we decide later on that it's not fast enough, okay, we need to have another region in maybe the United States, we can then put up a new infrastructure there and find a way to get our applications to work with together with the infrastructure in Europe. For example, by the time we start working with Kubernetes, you understand that it uses what is called worker nodes, and then you can spread your worker nodes across different regions so that it dynamically serves requests to your customers based on location and things like that. So there's a lot of amazing things that you can do, and these things change a lot as business requirements change. You can deploy an application, you start monitoring it, and over time you begin to have a number of issues as the customer base grows. And these kind of things lead to new customer requirements, new business requirements that requires your infrastructure to start changing slightly. And that's why you'll always need your solutions architects, your DevOps engineers to keep on working, keep on updating things as the need arises. So for now, our infrastructure is going to be in Europe. So what we'll do is we'll just put a text. So I've dragged this menu right here called text. And what I'm going to do is let me search for AWS regions in Europe. So let's see. Because each of those regions actually have names. They have a way that Amazon identifies them. So let's see. This is not giving us what I'm looking for. Let's see, this will give it to us. Okay, there we go. So region name, so this is US East. I'm looking for Europe. Okay, so we have in Europe, we have in Frankfurt, Ireland, and London. So the one in London is EU West 2. So we can decide we're going to use that. So I'm going to copy that. And then we can just name this EU West 2. So let's drag that slide. So, okay. Now, EU West 2 shows that it is in London. Okay. But let me see, availability zones. Now we need to talk about availability zones. Let me see. Okay, let's just search in Google. So AWS availability zones in EU West 2. Let's see if this is part of the documentation. So one good thing is AWS does a fantastic job with their documentation. They keep things up to date, so you can always rely on them. Okay, so let's see. So this is US. They usually have, okay, yeah, I think this is it. Okay, it doesn't really have that. Okay, let's have a look at this global infrastructure. No. Okay, anyway, rather than just spend time looking for that. So what I'm going to do, I'm just going to do the description. So it's possible that they have in London a data center in, let's say, Essex. So Essex is a part of England, right? So, okay, in London, we have, yeah, even in Essex, if you know a bit of London, Barking is part of Essex in London as well. So let's assume they have a data center in Barking, right? So that could potentially be called EU West 2A, okay? So a whole data center is a part of London in Barking. And then let's say in West London, does anybody know anywhere in West London? Let's assume in West London, there's another data center there, and it's called EU West 2B. So we're just assuming things here. Okay. Now, these are two availability zones, which means that you can have a set of your infrastructure in this zone and another in this zone. So what we're going to do, first of all, let's, okay, what I'm going to do is I'm going to drag this rectangle and then I'll switch it around. So you see this icon here, if you click on it, you can use it to switch things around. Okay, and then bring this here. So, and then enlarge this. Okay. All right, so let's see. All right, so I'm going to copy this, paste it, and move it. All right, let's move this to the side. Oops. So what I want to move is this. Okay, this is where some of these things can give us problem. Okay, never mind, because I was trying to move this onto the side, but it's okay. So we can then have, and this thing has gone back. So let me see if I can send it to front. Good. Okay, so now we have an availability zone, which means we're going to be putting some of our infrastructure in this part of London. So we're in London, but this part of London has it has a data center. So some of our servers are going to be in this part of London. And then we have some of our infrastructure that will be running in this other part. Oops. Okay. Let me bring it back again to the front and then drag that. Okay, good. All right, making sense so far? Okay, all right. So we have our VPC, which is our infrastructure private network. And then we've decided the region we're going to be putting our infrastructure. And within that region, we now know that it's going to be in this set of availability zones. So it's possible that Amazon has more availability zones. So you can choose to use 2, 3, 4. It all depends on, for example, your SLAs. If you have an SLA to make your applications available 99.9999999, there's a way they calculate the 99 or the nines, okay? So depending on the level of nines, for example, 99.9 is not the same thing as 99.99999. Apologies, my voice suddenly started acting funny. Okay, so if you require to be like highly available to the highest number of nines, then of course you are going to need to have more than 2 availability zones. Just because what if 2 availability zones, the whole data center goes down at the same time? The chances of you being up and running is not the same as if you had 4 different availability zones. But bear in mind, the more availability zones you have, the more cloud costs you're going to have. Because if you have 3 servers in this AZ, 3 servers in this AZ, even though this AZ is doing the same thing as this other AZ, it means you're spending double of what you would have had if you were running on one AZ. But you do know that if you run on one AZ, you have a single point of failure, because if anything happens in this AZ, you don't have a backup, you don't have anything to fall over on. So that's why solutions architect takes requirements from the business. What is our SLA on availability? Things like that will help you decide whether to have just 2 or 3 or more availability zones. So you'd always have to check with AWS to know how many AZs are available in a particular region. Some regions have just 2 availability zones. Some regions have up to 6 availability zones. So you have to check with AWS documentations on that. So we've chosen our availability zones based on the region. We know we only will have 2, probably because we don't have a huge SLA. An SLA basically is a service level agreement. So if you're running a software for a B2B client and your B2B customers have signed an agreement, and that agreement, you would have identified the SLAs in there to say we will always be available, so, and you've designed your infrastructure to support that. Okay. Now, so we have made our decision on that. So the next thing we want to do is we want to have our subnets divided. Okay, so a subnet is when you have a network and then you further divide your network into sub networks. And there's a lot of reasons why you want to do that. You can do that for logical separation of your infrastructure. So if you have a layer that is just going to be focused on compute, you can have a subnet for that. If you're going to have a layer that is going to be focusing only on proxying, you have a subnet for that. You can have a layer focusing only on data so that anything persistent is going to be there. So if you have further logical reasons why you want to separate your networks, you can do that. So with a click of a button, Amazon makes it easy to just separate your networks and just have that kind of design. Now you can also further separate them for networking, for security reasons, because, like I said, when we were going through the whole infrastructure, that you can have a DevOps engineer who would have, okay, actually, let me bring that diagram up so that we can see it. So rather than have your DevOps engineer access your database, maybe you don't want your DevOps engineers. Well, actually, that's not quite right, because, DevOps engineers have admin access to everything because they're spinning up the infrastructure in the first place. But let's talk about the developers, because developers don't have access to production. And so you can decide and say, okay, we're going to give access to our DevOps engineers and software developers, okay? But the only part we want our developers to have access to is the actual application servers that they work on. So you can separate your network such that your databases are separate, and then you configure security group such that only, okay, let's say, for example, this is where we want our developers to have access to Nginx, only to have access to Nginx, not even our application servers. You can configure these subnets to have access only to the subnet where the, this subnet where the proxy is will not have access directly to the subnet where the application is, okay? Where the database is. Now, even though your servers need access to these other subnets where your application is, this compute subnet, but you can still limit the access based on HTTP protocol. So this subnet will have access to this subnet where your applications are running, but only on HTTP. But you won't have SSH access, so that when developers jump onto this server, they can't jump onto this server and then jump onto this server. I'm only trying to give you some ways in which you can design your infrastructure and separate your networks for different reasons, security reasons, and things like that. Imagine you didn't have any reason to separate your network and everything is just running in the same subnet. It's from a security perspective, it just doesn't make sense because, everything and everyone will have access immediately just because they're all running in the same subnet. Okay. So let's take that away and then go back to what we're trying to build. So what we're going to do is we can use this round rectangle and then just bring it in here so that we can have a subnet here. Okay, so this can represent our subnet. So we can copy this and paste. So this is another subnet. So we're going to have 4 subnets. Okay. So let's just try to have them aligned together. All right, so I can hold on to this and do control. So if you press control, if you're using Mac, you press command. If you're using Windows, you can press control and then click on it. Okay, and then do copy. So control C, control V, so that we can have everything at once. So it makes it easy. So basically, remember, whatever we're going to have in this availability zone, we are replicating it in this other availability zone for HA, DR, and stuff. Okay. All right. So now we have our networks separated. What we now want to do is to decide which one is a private subnet, which one is a public subnet. Okay. And we'll give them, let's see. So this is going to be public. Okay. So this is a public subnet. Actually. Okay, so these are public subnet. All right. And then they will have what is called a network CIDR. So the CIDR, let me take, so this could be 10.0.1.0/24. Okay. So these numbers, when we start implementing, I'll show you how these numbers can be calculated. There's a tool online that we can use, but basically it helps us to know how many IP addresses can be created within this subnet. Okay, so the VPC itself is going to have its own CIDR. So let's say, for example, in the VPC, it can have a CIDR of 10.0.0.0/16, which will give us about 65,000 IP addresses. Okay, and then this one can be .2, right? .2. So you can tell now that the IP addresses in these subnets, we can have with /24, we can have about 255 IP addresses. So that means we can have virtual machines up to 255 in there. And then the one of the servers could be 10.0.1.0. Another one could be 10.0.0.1.1.2 and like that. And then here you can now have 10.0.2.1.2.2.2.3, and you can see we're not having separation, and there won't be overlap. Okay. Then we can have a private IP address or subnet. So this is going to be a private subnet, and this can be free. All right, so let's just drag them all. We need one more. Okay. So we can then change this is 4. This is 4. 5. Oh, sorry. Not 4. This is 5. Because it can be the same, right? Okay. 6. 7. 8. All right, cool. So now we have, we're building our network, we're designing our infrastructure, and it's time to now start putting some services in there. So remember, let's start first of all with our engineers, how they're going to be able to begin to put things and access the infrastructure. Someone said I skipped 3. Did I actually? Oh, I did actually. Thank you. Okay. But you understand the concept, right? So we're going to be using the other design anyway. So, but actually, maybe I could just use it. 4, 5. It won't take long, trust me. Oops. 3, 4, 5, 6. Oh, 7, 8. Oh, okay. So we're good. All right. So now, first of all, we know our DevOps engineer needs to hop onto this public subnet. But when you're creating infrastructure and you're separating the subnet, you see, all the subnets by default are all private when you create them. They're all private by default. Okay. So there's only one thing you need to do to turn a private IP into a public subnet, rather. A public subnet, a private subnet into a public subnet. And that is when you now attach an internet gateway to that subnet. So if you say AWS IGW, let's search. Okay, we'll see internet. Okay, so this is internet gateway. So there's a software component in AWS you can create that makes a subnet a public subnet. You see, this internet gateway, you actually attach it to the VPC, right? You attach it to the VPC, and then what you're going to do is you're going to create what is called root. Okay, so you have a root table. So the root table basically stores the routing information that helps servers to know how to route to and from a place. So with this routing table, you can then specify the internet gateway to say to access the internet or for the internet to access it, it holds the information about the internet gateway that makes that a possibility. So with this routing table, it makes it possible for this subnet to become a public subnet. Okay. So we're going to do the same for this other subnet. And this is what makes it a public subnet. So with that, you can then have your EC2 server. So you can provision an EC2. Should we use EC2? Okay, we can actually. And then we name it, oops. And then we just name it, so I'll double click on it and name it Bastion. Okay. So we can then have our Bastion server in there. All right. So with this setup, our guy can now do SSH onto the Bastion server. So that's how he's going to be able to access this. So let me see. To front. Okay, cool. All right. Now, so we can have the Bastion server here we can also have here as well. Remember, we're basically replicating the whole thing, but so that we won't have too many arrows and make our diagram look dirty and ugly too quickly. So we just leave it. But as long as you understand the concept, we're basically replicating the same thing. We can copy and put it there. Oops. So we can put it here just to show that there's going to be a Bastion server here as well. Obviously, that's how we're going to do it. So this is going to be our proxy network where we're going to put our Nginx server. So we can okay, one second. I'm going to respond to you now, Eric. So Nginx. So we can have Nginx here. And then we have Nginx here as well. So we've dedicated this subnet to our proxy because it's doing reverse proxy. So Eric has asked the question, what's the determination using /16 versus /24 since all have enough IP address to use? So, okay, I think this is the point where we use that website. So IP address calculator. Okay, so I'll put some calculator. Okay, so what's going to happen is, say we do a /16. Is it IPv6? Okay, so number of hosts to, okay, so let's go back. This doesn't have slash. It's a different sites that I've used before. One second, that's fine. Okay, this one I've used. Okay, so /16 and I'm looking for where I'm going to click to calculate. Because it should just tell us how many IP addresses it's going to provide. Don't know if it's this one. Okay, one second. Okay, yeah, this is the one I'm looking for. So basically, you can just put an IP address and then you do a slash. Okay, so with this, it's done the calculation and it tells us there is 65,000 hosts that we can have. So what that means is within this whole VPC as a whole, we can have up to 65,000 IP addresses, okay? So all the subnets will be subdivided such that it can total up to the 65,000. Now /24, let's see what that's going to give us. So that gives us 254. So each of these subnets will give us 254. So of course, there may be need for more IP addresses later so that you can create more subnets, because it's possible for you to exhaust the number of IP addresses in a subnet, and you may need to create more servers later on. And I've seen that become a lot of issues, in the real world, in production, where, there's an exhaustion of the number of IP addresses available. So there are multiple ways to deal with such situations. For example, creating more subnets as long as there is availability in your VPC. But sometimes you are aware of this information right from the start, right from understanding the requirements of the solution you are creating. So you already have an idea of how many IP addresses that you're going to be needing, based on your expectation of auto scaling as well. When your servers begin to scale, how many customers you're going to be servicing, how many applications or subdomains that you're going to be using, in this infrastructure. So some of these things are estimated right from the start, and then you can guess and have your infrastructure configured to support the expectations that you have right from the start. So even though you can start out not using everything, but you have already planned out future growth into it. Okay. So Eric is saying with this design, it's better to use /17 for the subnet as it's half of the /16. So again, this is, we don't have a particular requirement, for that. So this is for learning purposes. And of course, if that's what makes sense for what you're trying to do, by all means, go ahead and do it. And then this is one of the situations where, as a solutions architect, you want to have enough information about things like this, because you make such decisions and then people will question you as to why you've made a decision to do this and that. Okay, so so if we were to carry on, what we have now is we have our Nginx and our private subnet. Okay, and of course, we have security group that we're going to configure. So we may not show security groups in this configuration or in this diagram. When we start implementing, we can do that. But you may also want to show that as well. Let me see if there's any icon for security group. Okay, there's nothing like that. Security. So it's nothing like that. But anyway, if there's a way to specify what security groups are going to happen there, that's fine. But we'll do that during our implementation. Okay, so the next thing is to now have, we can actually just do something. Let's put a text so that we can easily tell what this is about. So this is our proxy subnet. Okay, so we know what it is. So this is our compute. Okay, which is where the business application is actually going to be running. And this is our data layer. Okay, so now that we know that, we know we're going to be needing more servers here. So this is going to be our, so we can have our first application. So this can be WordPress. So assuming one of the applications we're going to be deploying there is WordPress, and this other one is our tooling application. So if in your situation, you're using maybe the same subdomain in the same organization, you can actually just specify whatever it is, okay? And then we're going to have RDS. So RDS is relational database service. Okay, so rather than deal with backup, restore, performance tuning, replication, and all those things manually, Amazon makes it possible for you to just spin up a service, and out of the box, you have all of that ready to go. So they have RDS for MySQL, for PostgreSQL, for different database management systems, Oracle, SQL Server. And they also have MySQL Aurora AWS Aurora for MySQL. So Aurora, so don't confuse Aurora with RDS. So Aurora is Amazon's version of the relational database management system. So if you choose to use RDS, what you're essentially doing is RDS for MySQL is basically MySQL as a service. Okay. But Amazon has now taken a fork of the MySQL application, which is the RDBMS. They've now optimized it for AWS. So they believe is a lot faster. It works well, integrates well with AWS because they developed it to suit for that purpose. So they will highly recommend for you to use Aurora rather than RDS because it's been optimized to work with Amazon. Okay. So whether it's Aurora, we can even choose to use Aurora. We can say this is MySQL Aurora. Okay. Doesn't matter whether Aurora or RDS. So these are design decisions. Okay. And then we can have a replica of it in another AZ. So Akinwumi has asked what's a tooling application. So a tooling application could be it's a business application. So it's a fictional application that we have decided to create that you can use to deploy applications and just see how it works. So it's just like any other application. It could be a finance application or HR application or whatever business logic application that you're working with. Okay, so we've just calling, let me just say tooling business app. So it's just like an app that your organization is deploying. Okay. All right. For practical purposes, can Amazon services be deployed through a virtual machine instead of the AWS side? What does that mean? Don't quite understand what that question is. Okay, while I'm waiting for that. Yes, so Akiomi, yes. So a different subdomain. So for example, this WordPress could be maybe okay, let me show you an example. So I think we have support.dare.io. So this is a subdomain of dare.io. So imagine this support.dare.io is actually a different site to our actual main website. So this site is being powered by this part of the infrastructure. And then dare.io, the main site, can actually be this part of the infrastructure, something like that. Okay. All right. So we have all this set up. So now I think it's time to now walk through the flow of how our traffic is going to flow through. But one more thing for the data layer is EFS. So if you've been working with NFS in previous projects, you would know that this is NFS as a service. So you can see what Amazon is doing. They're making life easy for you. So rather than installing NFS and configuring NFS and doing all of that, they actually make it available as a service. You don't need to install, configure, manage, or do anything. Just provision it and it's ready to go. Mount it on your servers and it's ready to go. So it's called EFS. And because it's going to be storing data, ideally, you should put it here, which is in the data layer. But unfortunately, we're going to put it here. And the reason for that is just because it's the way EFS works. It has to be in the same subnet with the applications that's going to be needing it. So because we're going to be mounting the mount point onto the servers that need it, it has to be in the private subnet. So I don't know how to represent this, but let me just do a copy first of all. But actually, technically, it's just one. Okay, so EFA is just going to be one, and that one is going to be where we'll be doing the mount point. Okay, so what I mean is, I'm assuming I didn't put that here. I think it should be something like this, which the EFS will now have mount points that each of these will use. So they're all going to be using the same mount point so that any if you log onto the server here and you do ls on the file system that's been mounted onto EFS, you would think it's local to the server, but it's actually writing data, in some server that Amazon is managing, that the EFS software is sitting on top. Okay, but just for the sake of your understanding about, actually, maybe we can do that. You know what? We'll just leave it here for now. Okay, but what I want to buttress is the fact that it's part of the subnet. Okay, that this is okay. What we'll do is actually let's put it here. So we just separate the mount points during implementation. Okay. All right. Cool. Then so there's a few more things we need to do, which is the flow of the traffic right from the top. So I'm actually thinking we should stop here today so that I'm worried about information overload so that you guys can digest everything we've been talking about. And then tomorrow we'll spend maybe just 15 to 20 more minutes to complete this diagram, and then we can swing straight into the implementation. Sounds good? Any questions so far? All right, cool. So it's good to know that there isn't any question. Yeah, same time tomorrow, 8 p.m. We're going to carry on. And then I'll be looking forward to see you guys. Samuel is raising up his hand. Adebola also raising up is the one from the previous. The recording won't be available tonight. It takes a bit of time to render. So by tomorrow, Solomon is going to send it out. So look out in your email for that. Okay, thank you.
Okay. Can I go ahead?
Yes, carry on.
All right. Thank you so much for a job well done. Grateful, sir.
Thank you.
My name is Samuel. So I just want to ask, is there like an automated app that one can use to kind of automate this process?
Of course. Definitely. Now, but let me ask, are you saying the process of designing the infrastructure or the actual implementation of the whole thing when we start implementation?
After deploying, yeah, the
actual implementation, right?
Yes, sir.
Yes. So there is a software called Terraform, and that's what we talked about here. Okay. So everything that we've designed, when it now start implementing, we're actually going to use Terraform to automate everything. So it's going to create the VPC, the subnets, the servers, everything will be automated, and just by clicking, running the scripts that you've configured, it's just going to build everything out. Okay. Yes. But before we do that, we're actually going to do a manual implementation first, because that's very, very important for you to visually see the flow of everything. Because if we just swing straight into writing a code to do it, you will definitely get lost. Okay.
Thank you so much. Yeah, thank you.
No problem. All right. Okay. So I'm gonna stop the recording and end the session now. So I look forward to seeing you tomorrow evening, and have a great evening. Akim is asking, I made reference to past recording to the one. Yes, I'll send that out tomorrow. So after tomorrow's session, I'll send out the past recording so that during the week you can spend time to watch that ahead of the next one. Okay. All right, then. And then,
hey, Harry, I have a question.
Yes.
So my question in relation to deploying the projects on a virtual machine is because I'm being charged whenever I use the AWS site because I'm doing some other stuff there. So it like goes overboard the limit of what I have to use. So my question is it possible to run all those projects solely on virtual machines?
Do you mean this particular project or even future project that we'll be doing?
No, the projects we have to work on, like project 1 and all the rest. Because I know when you started, the first video, so it was
Right.
on the virtual
Okay.
machine, then you switched.
Okay, I see what you mean. Like using the local virtual machine, virtual box and stuff to
Yes,
do.
yes.
Yeah, so the early projects you can do, okay, if you're able to navigate yourself around installing virtual box and dealing with some of the issues that may come up. It can be frustrating setting up virtual box at first, but once you get it sorted out, you can actually do like project 1, 2, 3, I think all the way to like probably even probably up to project 14 actually. Okay, but from project 15 is where you really then start to work with AWS proper. Okay, so you can do that. The reason why we recommend AWS right from project 1 is because so that you start getting used to AWS right from the start, getting the SSH keys, configuring security group, all those kind of things just sort of make sense right from the start, you know. But if it's costing you a lot, you can consider VirtualBox. In terms of the cost, I know some people have actually applied for AWS credit worth about $300. So I'll get the link for that and share it with everyone in the general channel so that you can apply for $300 and it's quite helpful. The only caveat to that is you might need a custom domain. So you might need to like register for a domain to be able to apply. I think they only give it to corporate domains. So, but I'll get that information and set it out. So you might explore that option.
Thank you.
Yes. And Cynthia just mentioned you can set up a budget for yourself and alert. So of course you can set up a budget and just put an alert there to alert you when it's hitting that budget so that you don't exceed that. All right. Godwin, looks like
Hi, Derek. How you doing? Today's my
Yeah.
first day joining your section, and honestly, I love your class because I had zero knowledge of what was going on. But I've been in the IT field for more than 10 years now. I've done several things in IT. I've done relational database. In fact, I started with Oracle 11G, the G4 grade relational database. And I also went to CCNA networking, and I also did cybersecurity. In fact, I've been everywhere in IT. And when I came across your what's the word I'm looking for? Your webinar, I was like, hey, you can be a DevOps. Even if you did not even go to school to become a computer scientist, you can actually just get the knowledge. I was like, hey, look at me that went to school, have a bachelor's degree in computer science, and he's telling me that I can do it. So I was like, okay, let me just give it a try out. And today was my first time actually doing a masterclass, and I was able to catch up a lot of information that I knew in the past, and they were similarly making sense to me right now. So my question is, I haven't really done the project from 1, 2, 3, 4, 5. Is there a link you can provide to me that I could just follow up so that the next class I can be up to speed with wherever you guys are? All right.
Absolutely. So what I would recommend that you do is immediately after this session, just send an email. Okay, I'm going to post that now. Okay, so once you send an email, we'll pick it up from there. Actually, I sent it directly to Evie. So let me send that again. Okay.
Thank you.
All right. So send an email. I will just watch out for that and then we'll pick it up after that to understand where exactly you are. But given your experience, I mean, the fact that you mentioned Oracle already tells me that you have Linux experience already because, working on Oracle means you're able to, as a DBA, you must have worked on Linux. So
Yes, I'm familiar with Linux systems, Linux command.
It may actually be sufficient for you to just carry on from project 15 upwards, because from project 1 really is more about very early days, people with zero to little experience in tech in general. But however, I highly also recommend to still go through project 1 and all that. The only difference is if it's going to take a newbie maybe 1 month to do 2 projects, it'll probably take you 1 day or few hours if that makes sense. But you
Yeah.
still get to follow the flow up until the point where we get to prayer 15 and then carry on from there. Because most of those projects have been designed to follow on from each other, more like a story line that you're following. And it then makes a lot more sense as you graduate up the ladder.
Okay.
Okay. So yeah,
Sounds
so
good.
let's take for that. Thanks for the compliment as well.
Yes, sir. You're doing great, sir. Thank you.
Thank you. Okay. So do we have any more questions before we call it an evening, and then we'll see you again tomorrow? Okay. All right. All right, then. I'll see you guys tomorrow. Have a blessed evening and stay safe.